Our chemical reactions are really talking about that bonding being broken and reformed between atoms, ions, molecules, all these different things. We should know that we have reactants, which are what you start with, versus products, what you end with in a chemical reaction. And then we've got some different types of chemical reactions that we're going to talk about. We should know that to synthesize means to make. So a synthesis reaction is going to be making a more complex structure. So for example, A plus B gives you AB. So we're talking about simple molecules combining to create a more complex molecule or more complex compound because we're making something. So this is kind of what we're talking about with growth and repair. So the idea that being able to create and build more protein for building muscle out of the foods that you eat is really based on combining and synthesis reactions. Decomposition, to decompose, we're talking about to break down. So that means that in a decomposition reaction, we're really going to have a breaking down of bonds into a more simple form. So now we have a complex compound or complex molecule is our reactant, while our products are going to be a simple, more broken down form. So for example, important in digestion, the idea of having starch, and when we break down starch, we get glucose bonded with glucose, etc. So we decompose, we break down the large molecule into more simple forms. An exchange reaction, all right, is exactly exchange like we're talking about. It's almost like a flip-flop. So you can see that we have AB plus CD. So what happens is that the A and the D are going to join together while the B and the C are going to join together. So you kind of have a trading of places that occurs. So we're talking about that acid-base reactions. All right, we'll focus out a little bit more in the next lesson. Being when acids and bases react together, you ultimately get some water and salt that are being produced. So you get that flip-flop exchange. And then a reversible reaction is pretty self-explanatory, the idea that the reaction can occur in either direction. A really great example of a reverse reaction is talking about ADP plus P can go back and forth with ATP. We should know that adenosine triphosphate can be broken down into ADP, its uncharged version, with that phosphate being free floating around, and when it goes to the mitochondria, these two individual molecules or individual substances can be recombined back into the ATP. When the ATP goes out into the cell, it gets used, and as it gets used, it gets broken apart. This pretty much wraps it up for our lesson on chemical reactions. If you guys have any questions, please feel free to see me.